Hi, my name is Kavya Ravi, and my topic is about gearbox fault diagnosis using deep learning with simulator data. So, this paper extends to the prevention of major gearbox failures by recognizing cracks and managing maintenance schedules. Basically, gearboxes are used in almost all transmission system and power system. We can see that in vehicles, wind turbines, helicopters, and even in bucket wheel evacuators. So, over the lifespan of any piece of equipment, component will wear and eventually fail without proper maintenance upkeep. So, this causes the failure. Several vibration-based techniques, diagnostic approaches have been proposed using machine learning and deep learning algorithms to automatically identify and classify faults in gearboxes. The proposed detection strategy is tested through simulation vibration signal and experimental vibrational signal. So we do have six methodologies to test this. One is the one-stage gearbox dynamic model. This was done earlier stage. So this model was used to compute the dynamic response of a single-stage gear system. And the other one is the tooth profile error model. And this is the most realistic representation of the signal. The effects of the tooth profile error were included in the dynamic response of the system. And others, the altitude Gaussian white noise. So after all the data sets were generated with different TP levels, white Gaussian noise with different signal to noise ratio were added to all signals to simulate close to real life condition. And the other one is feature extraction and traditional machine learning classifiers. And at last, the convolutional neural network is that's one of the most common DL methods that are very popular for visual recognition. So, in this research, to take the advantage of the visual recognition of the convolutional neural networks, the time series of vibration data were encoded to images and fed to CNN. Three different imaging methods were used to transform the time series of vibration data into 2D images. These images are called as the spectrogram, Brownian angular displacement field. So, a spectrogram is a tool to visualize the spectrum of the frequencies of a signal, and GADF is an encoding method to encode the time series of data into images. It transforms 1D data into symmetric matrix called the gram matrix. And the results have shown that the microgeometrical nature of the TPE added considerable complexity to the simulated signal, which brought more difficulty to some classification algorithms to detect and identify the presence of crack in the rear tooth. So the TPE is nothing but it's the one side of the tooth in a cross section between the outside circle and the root circle of the gear. It normally refers to the curve of the intersection of a tooth surface and the plane of a surface normal to the pit surface, such as the traverse, normal, or axial plane. And the proportional method can successfully identify gear failure and effectively detect single tooth failure on a gear. So, although CNN is a very popular tool for image recognition and classification, it is proved that it performs the best among all other methods with raw vibration signal. Thank you.